Welcome to GATE 2021 Model Questions and Control Systems. Today's our topic is Stability Analysis. Question number 2. The open loop transfer function of unity feedback system is G of S is equals to given K into S plus 1 whole square by X cube into S plus 10 whole square. Determine the range of K for closed loop system stability. These are the options shown. Let us go for the solution. So this is the open loop transfer function. So these things we are exploring in the previous topics also in the root laws technique. Everywhere we have discussed about these concepts. But we didn't given the numerical data for you. Already we explained about this concept of lead system connecting for the 3 poles lying at origin. But in the previous topics we already explained that how will be the phase plot of this system is, since there are 3 poles at origin, we'll have the starting angle as minus 270 degrees. And S plus 1 by S plus 10 whole square is 2 lead systems connected, whose phase plot will be in this manner. And here alpha value is 1 by 10. You can refer for the previous root laws topic question regarding this alpha value and all this phase angle calculations. And what is the phase angle? We got it as minus 160 degrees. And definitely this phase plot will cut minus 180 degrees for 2 frequencies, that is omega PC1 and omega PC2. So this omega PC1, omega PC2 are nothing but the oscillating frequency zone, where the root loss plot will cut j omega axis plus r minus j omega PC1 plus r minus j omega PC2. That we explained in the last classes in the root loss topic, all this data. You can refer for that one who has not seen the video. Now your question is the numerical data they're asking. So this is one of the problem which becomes more tedious to solve by using an Author-Which criterion, the range of K for closed loop stability. Then the easiest method is frequency domain method. But definitely you can find the omega PC1, omega PC2 of that question by using your definition. How to find the phase crossover frequency is angle of the open loop transfer function equated to minus 180 degrees and solve it. What is the angle of this open loop transfer function is? K by j omega whole cube angle will be minus 270 degrees plus 2 j omega plus 1 whole square angle is plus 2 tan inverse of omega minus 1 by j omega plus 10 whole square angle is minus 2 tan inverse of omega by 10 is equals to minus 180 degrees. Okay, then from here 2 times of tan inverse of x minus tan inverse of y, we can write it as x minus y by 1 plus xy is equal to minus 180 plus 270 is 90 degrees. Then tan inverse of the numerator part will be 9 omega, denominator part will be 10 plus omega square is equal to 90 by 2 is 45 degrees, and tan 45 is 1, hence therefore 9 omega equal to 10 plus omega square. Omega square minus 9 omega plus 10 equal to 0. From here if we solve it, we get 2 phase crossover frequencies. Omega PC1 will be getting as 1.298 radians per second, and one more frequency omega PC2 will be 7.7 radians per second. So these are your phase crossover frequencies. For hence the root loss diagram compulsory cuts 2 times your positive imaginary axis. One is at plus j omega PC1, another one will be plus j omega PC2. From here we can know it. Exactly what gain they will cut it, that we have to do this calculation. The magnitude of open loop transfer function at phase crossover frequency, we find it, that is actually reciprocal of gain margin only. It is means because gain margin is defined as reciprocal of magnitude of open loop transfer function at phase crossover frequency. And already we know that the gain margin is critical gain by actual gain. Critical gain means the gain for margin stability. From here it is nothing but K by Kc. Okay, if you find magnitude of open loop transfer function at phase crossover frequency and keep in this model K by Kc, That case itself will give the critical gain or gain for margin stability. So let us find the magnitude of open loop transfer function at first phase crossover frequency. What is the magnitude? Is k by omega cube. This will be root of omega square plus 1 whole square, will be omega square plus 1. Denominator part will be root of omega square plus 100 whole square, will be omega square plus 100. Substitute first case phase crossover frequency 1.298. And if you simplify this one, what is the k by denominator part will be getting as 82.8. Therefore, this is only where KC1, that is what value of gain k, the root lowest plot, first it will cut imaginary axis, KC1, that is 82.8. Similarly, you can find KC2. Magnitude of open loop transfer function at second case phase crossover frequency will be, the magnitude is same only. Substitute omega equal to omega PC2. What is omega PC2? You got it as 7.7. When you substitute it, you will get k by 1206.2. So this is only where second value of gain k, where the root lowest plot will cuts imaginary axis. So these are your critical gains. Now I'll draw the root lowest plot for the same question, and we can tell the range of gain k for stability using root locus technique first. So there are 3 poles are lying at origin, and next double zero, double pole. At k equal to 0, all the closed loop poles are open loop poles. Infinite gain, open loop zeros. And where the root lowest lies on the real axis, that regions will thicket. Where the root lowest lies on the real axis, obviously between 0 to -1 and -1 to -10, and also -10 to infinity. Then what will be the angle of departure of these 2 poles? Is one is 0 degrees, another 180 degrees. One of this pole will depart with 180. How many asymptotes totally we have? It is 3, and 3 asymptotic angles are 60, 180, 300. For this branch only terminates with 180 degrees. Remaining these 2 poles will break and terminates with 60 degrees. But how many times it will cut positive imaginary axis? 2 times. Hence, like this. 2 times it will cut. First one is plus j omega PC1. What is omega PC1? You got this 1.298. What gain it will cut is, that is only KC1, which will be 82.8. And a second time it will cuts where is here plus j omega PC2. What is omega PC2? Got it as 7.7. And what is the gain it will cuts is KC2. What you got is 1206.2. Similarly, one more branch will go with the -60 degrees or 300 degrees as k tends to infinity. Again cuts where is minus j omega PC1 is minus j 1.298 for same gain 82.8, and here minus j 7.7. What gain is 1206.2. From here we can tell the what is the range of gain k for stability, instability, even margin stability using this root lowest plot. Really, if it is cutting 3 times imaginary axis, then how to draw that plot is like this: 1, 2, 2, 3. Only one time means like this. Only one time, like this you have to draw. 2 times cutting means compulsory you have to go like this only. Then only it will comes 2 times. 4 times if it is cutting means 1, 2, 3, necessity 4 times. For in this manner, how many times the phase plot will cut -180 degrees? That many times the root loss will be cutting your positive imaginary axis. With that information, you can write the range of gain k for stability, same thing. Now from k greater than 0 to until less than 82.8, 2 complex poles are lying in the RHP. Therefore, k greater than 0, less than 82.8, your system is unstable only. Exactly for k is equals to 82.8, the closed loop system is marginally stable. And again for k greater than 82.82 until less than 1206.2, all the 5 closed loop poles are in LHP stable. That is this one. Actually, this is only your answer also for your given question asked. What is the range of gain K for closed loop system to be stable? This is only your answer actually. Next, again for K is equals to 1206.2 margin stable. Again, K greater than 1206.2 to up to infinity, the closed loop system is unstable for us. Like this, we can easily analyze from the root loss plot what is the range of gain K for closed loop system stability. If you see your option, which option is satisfying, that answer is option B only. Hence, your answer is B when you directly analyze with your root loss technique. The same question still you can analyze with the polar plot using concept of enclosed also. Or how the polar plot is? At zero frequency, what is angle? We have it is minus 270. Infinite frequency also minus 270, but remaining frequencies already we have shown the phase plot increase and decrease, but cuts minus 180 degrees 2 times. Therefore, the plot starts at minus 270 degrees here and cuts minus 180 degrees or negative relaxes for 2 times. One time already cut, second time cuts and reaches to here. So this is the polar plot as omega varying from 0 to infinity. And first phase crossover frequency is this one, omega PC1. This is omega PC2. And what is this magnitude? Magnitude of open loop transfer function at that phase crossover frequencies, K by 82.8. This one is K by 1206.2. Now apply the concept of enclosed, we'll get your answer. Same answer, we'll get it. Whenever you are traveling in this arrow direction, this is only your right hand side. For a where if you locate minus 1 plus j0 point, it will not be enclosed is obviously in this region. If you locate minus 1 plus j0 point, then only the closed loop system will be stable. If you locate in this region or in this region, it will be unstable only. For therefore, two ranges of gain K, it will be unstable. Only one range of gain K, it will be stable. For where if you locate, if you want to locate minus 1 plus j0 point here, what is the range of gain K we require is compulsory K by 82.8 should be less than 1. That is K should be less than 82.8. Sorry. Wait for a minute. I'm extremely sorry for this. Very nice. If you want to locate minus 1 plus j0 point here means compulsory here to here the magnitude should be greater than 1. Sorry. K by 82.8 should be greater than 1. This K should be greater than 82.8. And if you want to locate minus 1 plus j0 point, K by 1206.2 magnitude should be less than 1. That is K by should be less than 1 means K should be less than 1206.2. But what is the range of gain K for stability is K should be greater than 82.8 but less than 1206.2. The same answer will get its stability. Unstable means if you want to locate, if you locate minus 1 plus j0 point, it becomes unstable. If you want to locate here, K should be greater than 0 until less than 82.8. Minus 1 plus j0 point locates there and encloses, and it is unstable system. Even if you locate minus 1 plus j0 point in this region also unstable. If you want to locate here means K should be greater than 1206.2, it will be unstable. And polar plot passes through minus 1 plus j0 point for what values of gain case? One is 82.8, another one is 1206.2. So that are the values of gain K for margin stability. Even if you analyze with your polar plot using concept of enclosed, we'll get the same answer. Even if you analyze with your root loss technique also, we'll have the same answer. But using RH criterion also, you can get the answer. But that will be more tedious for you when you solve it. Okay. Thank you. Any doubts, you can post in the comments.